Good evening, ladies and gentlemen. We are working on our 6 degrees of freedom movement controller today. Previously, we had done a bit of work on this by trying to implement uh, the system inside the pawn and blueprints. But it turns out blueprints don't have very good quaternion support, so we were unable to get the rotation working correctly. Um, basically, from what I was reading on the documentation, the rotators I was using were using one of the wrong quaternion function internally to do the math for what I wanted. Um, and so I'm re-implementing that in C++. And to re-implement that in C++, I've had to rebuild some stuff. Basically, I had to rebuild the entire project. So to start with, we're just going to get back to where we were, which should be pretty quick here. This is a player controller that I'm going to be adding enhanced input to, and I've got the input already set up. And then we'll be diving into the C++ after that. Um, so I've gone ahead and pulled up the Unreal Engine 5 documentation on enhanced input here. And because I don't remember the exact nodes we need, I remember they were hard to find. Okay, so add mapping context. That's why it's hard to find. This node doesn't say anything about input or anything about yeah, it doesn't say anything about input. It just says add mapping context. That's a very weird sounding node. So according to the documentation, we need to cast this to a player controller first. Looks like that's right. Cast to player controller. This is derived from player. Whoa! This is derived from player controller, so casting to it should not be an issue. Wow, that went way up there. And then as player controller, we want to add a mapping context, not a message. Not a message. We want to add the mapping context. I think we have to do this. Yeah, I think we need to not be context sensitive here. Because we need to cast this player controller to an enhanced local input subsystem. Enhanced input local it's not quite what I'm looking for. There we go. That's what I'm looking for. And then, of course, we want this to be a reference to self. Missed the O, controller. Okay, controller. Okay, so self, we're going to cast to a player controller. We're going to get the input subsystems of that and add a mapping context. Oh, and of course, the mapping context we want to add here is dev input. So now we've got the correct. Oh, don't like that. I'm not seeing why it doesn't like that. Did somebody do this on the pawn? Oh, why? The documentation I'm looking at is doing this on the pawn, which makes sense for like getting into vehicles and stuff, but doesn't really make sense here. There it is. Variables get a reference to self, and then we can do that. I'm wondering if we need to cast to a player controller here. I don't think we need to, because we're already a... That's our parent class. We shouldn't need to cast to our parent class. Close. Okay, one more thing we need to do is a game mode. Game mode base. Dev mode. And of course we want our player controller class to be dev player, and we want our default pawn class to be our base ship. Okay, that should do it. All right. So now, hopefully, when we go ahead and hit play, that should all work. We're about to find out. Okay. Looks good. Oh, we even have collision. How lovely. We didn't have collision last time. I don't know why. Huh. Wait. What? I don't... I don't know why rotation is working. I haven't implemented rotation at all. And this is not the kind of rotation I want to implement. And pressing any other... What on earth? Okay. I think that means we're not using the right pawn. I'm pretty sure that means we're not using the right pawn. Oh, obviously, because we didn't choose the game mode that we want to use. So edit project settings. Maps and modes, default game mode, we want to be dev mode. That might give us a little bit of a different result. Okay, we're still getting, okay, our movement's backwards. That's a good sign, and we don't have any rotation. Okay, we're using the correct class, finally. And no collision either. That's actually a little odd, but expected. Okay, so left and right are backwards. We'll go ahead and fix that real quick. All right, playing again, and we get left and right going the correct way. No rotation. All right. So now it's time for us to get into the C++. I am using, I'm trying out JetBrains Writer as my IDE right now. I'm liking it so far. Don't know if I'll stick with it or not. The big thing is it's easier to figure out what I need to rebuild to get Unreal Engine working with VS Code. Particularly on Linux, it's really hard to figure out what you need to rebuild and where. Although I think I could do it at this point. Okay, so basically the most of the movement that we are looking at is handled by the pawn movement component. A little bit is handled by floating pawn movement, but most of it is handled by the pawn movement component. So I'm going to be implementing new functions for the rotation based off of the velocity functions. So the first one I think we want to do is go ahead and do consume angular input vector here, which will be quite similar to consume input vector. So if we want to go to the the implementation here, we can see that this is a very simple if statement implementation. We return, so if there's a pawn owner, we return the that is not what I was expecting us to return. What is that? Pawn.age. Why is pawn consuming the input vector? Whoops, I think I clicked the wrong thing. There we go. Okay, so we have a input vector here, and we zero the vector and then return. We store the vector. Interesting. We don't declare a new vector here to store it in. We're storing it in a vector that's already part of the pawn. But we store it in the last control input vector and then zero our current vector and we return the last control input vector. So let's go ahead and take a look at where these are declared. Okay, looks like these are just simple vectors, uProperty transient. So we can go ahead and just add them right here. I think it is very strange that these are on the pawns and not on the pawn movement controllers. We'll see how it does. So we want to do rotation input vector. And we also, wow, wrong thing. Want to do a last rotation input vector. Okay, that's really all we need to declare this function. So we're going to go to our implementation here, and let's see here, that returns, and yeah, that returns an F vector, and in the current type space, we want to consume angular input vector. Okay, perfect. And then we can basically copy this, or well, not that one. We can copy this function and to here. So last rotation input vector is equal to rotation input vector, and then rotation input vector is equal to 0 vector. And then we want to return the last rotation input vector. Okay, simple implementation, and most of these will be pretty similar. Just implementing a duplicate of the velocity input vector so that we can handle rotation in a similar manner and go from there. All right. So next up is get last angular input vector. I'm going to add myself a reminder here because if I don't add it, I'm going to totally forget. We need to figure out where these were initialized. Or rather, where the input vector is initialized, and initialize these in the same way. Okay, so get last input yeah. So what are we returning here? This is well, obviously this is a vector because we're getting it. Get last angular input vector, and of course, same thing. We want to go to the definition, and we see this is actually getting the movement input vector from the pawn. It's interesting that they dropped movement here. I'm not sure why they did that. It makes me kind of want to see if there is a non-movement input vector, but I'm not. Oh, Unreal is very insistent on being on top sometimes. Yes, phrasing. Please ignore. All right, so this does look like it has some rotational input, although it applies it to the controller instead of the player. And it calls it on the player controller. This actually can probably be very useful to us, so I'm actually going to go ahead and open it. Rotation input on the player controller. This is really the thing we're trying to copy. But we want it on the pawn instead of the player controller because our pawn is what's really rotating in 6 degrees of freedom, not our camera in this case. I suppose you could technically rotate the camera instead of the pawn, But I think that would actually just make things harder. So typically, in a first-person shooter, they don't rotate the pawn unless they have to. They rotate the camera around the pawn, and then do some fancy stuff to calculate the static mesh, or the skeleton mesh look at and stuff like that. But I think in our case, it's actually going to be simpler to rotate the pawn itself. There's certainly some physics interactions. I'm thinking Descent 3 mass driver that actually knocks you around is definitely works better with a pawn rotation. So I think we'll do that still. And this is a rotator. We will have to figure that one out. I have it as a I have it as a vector, I believe. Fact that that's a rotator is interesting enough that we need to take a closer look. I actually find that's very interesting that it's a rotator, because we were not getting anywhere with rotators in Blueprint. So we have rotation input. Okay. All right, so we add pitch, we add yaw, we add roll. That's all pretty simple. I suppose we want to look at what that does. Pitch plus equals value times don't. For reference, all you beginning programmers out there, this is bad practice. This is what's called a ternary if statement. And basically, you use it if you have a single line if statement. It makes it easy to condense it all down to a single line, right? So an if statement with one statement, it would be the equivalent of, so this statement here is the equivalent of if not is look input ignored, do this, otherwise do this. So it's going to return 0 or this value. The problem, and that's perfectly fine. The problem is that this value has another ternary operator in it. So we have a nested if statement here. A nested if statement that is returning depreciated values. That is interesting. I suppose that's. And basically, if you are nesting your what's called a ternary if statement with a question mark, you probably should be pulling this out into if statements. The nested ternaries are very hard to read. Okay, so we're either returning input pitch scale depreciated or 1 or 0. Value, see what I mean about hard to read? We're either returning value times, okay, so I'm assuming we aren't using any legacy code, so we're either using value times 1 or we're using 0. Okay. And we're just assigning yaw pitch roll to the value directly. That's one way to do it. What was that? Rotation input. Actually, we probably want to search for it here. Rotation input. I assume that we've got a few places that we use it. Update rotation. This sounds like a good example function for us to look at. Calculate delta to be applied to on a view rotation. I've never seen an Unreal player controller do a roll for its input. I'd be really interested in looking at that. Not sure how to set that up off the top. View rotation equals get control rotation. Is there a way to view this in line? No, that's not it. View inline. Okay, we can view some stuff inline just by hovering over it. View the control rotation, get the control rotation. Jump to source. I really wanted to jump to how it's used. Okay, return control rotation. Is that the same thing that... is there a back? There's back. No, it's not. Rotation input and control rotation are different. That is interesting. Okay. Oh, obviously they should be different. This is the actual rotation. This is the input for the new rotation. Okay. Player camera manager, process view rotation, delta time, delta rotation. Close this, please. That looks weird. F. Local variable, delta rotation. I was expecting us to do something with this. Okay. Yeah, control rotation. If we have a camera manager, we'd process it. Oh, I suppose that's replacement for this function essentially. Get view target. Not camera manager, not view target, and not view target has our component. Okay. Then we apply rotation to the camera. Okay, there's a lot of steps in this. I think I'm going to ignore that is a rotator for now. We'll probably change it later though. What was I doing before? Oh, get last angular vector. So I was probably over here. Yeah. Turn. Last rotation input vector. I think I want to rename these. Oops. Just keeping everything consistent. All right. Save this. Head back over here. And then we want to effector and then the current context and get pending rotation input vector and looking at the pawn. We're just returning the rotation input vector directly. Okay. So we've got a couple more things to implement here. Whoop, don't do that. We need to implement actually performing the update. And we need to figure out where these were initialized. So let's take a look at the input vectors on pawn and see where they got initialized. They don't get initialized in pawn. That's interesting. That is very interesting. I suppose that makes sense. I am setting control input vector in blueprint, right? Add input vector right there. That's where I'm setting it. Okay, so that's the next thing to implement. Is add rotation input vector. Wow. Oh, there's add input vector right there. Oh, this looks pretty straightforward. Expecting this one to be hard. So, ooh. Okay, so what does this look like? If what? I'm confused. Oh no, if, or this is an or. So if this is a force, well, currently it's set up so this, if this is a force, we ignore it. Bool force is weird that we have this here. Okay. No. Rotation input vector plus equals rolled vector. So right now we are calling this a rolled vector. I'm not certain we want a rolled vector. We will get back to that. Okay. Well, what that means is I kind of want to reload this. I'm concerned about the build times though. So I'm going to hit build, and if it takes more than a few minutes, we're going to go ahead and switch over to Jess. I heard the ding. That sounds like it built and reloaded pretty quick. So This might work. And rotation. Okay, not work. Maybe I have to reload. Whoops. What did I do? He doesn't appear to be happy with me for some reason. I don't know why. Very unhappy. Uh-huh. I can feel my hard drive spin. I think I seriously need to get an SSD for this thing. I forgot the boot on an SSD. My data is all on a spinning disk. We going? Well. Meantime. Unreal made noise again. Okay. All right, so we need a new function here, I think, to apply rotation input to, or apply input to rotation, I think. There it is. Apply control input to rotation, sure. I'm going to rename that just input to rotation because we didn't call it control or rotation control input or control rotation input. We just called it rotation input. Okay, so void u flying movement component, apply input to rotation delta time, and so all these might be the wrong types. I might need to use quaternions here or rotators instead of vectors. But by getting the logic down, I can think about the types in a second. Rotation xl equals get pending rotation input vector dot get clamp to max size 1 f. This the first line here, what we're doing is we're just making sure that if you receive an input that is greater than 1, it locks it down to 1. So the maximum input it can receive is 1. And this, I think, log input modifier to squared. So if we are not negative, our input modifier should be the size of our acceleration input vector. Oops, spelled that wrong. If we are less than 1, I'm not sure how that's possible, then the input is 0. Max pawn speed. Perfect. We have a get max angular speed. Oh, because I made it get max angular speed. I'm pretty sure. Where'd you look at it? There it is. Okay. So constant bool b exceeding max rotation exceeding max angular speed is equal to where's this declared? I don't recognize this function. Movement component.h is exceeding max speed. Max speed is equal to math max of 0 and max speed. Okay, max speed squared equals squared. Constant Unreal, don't need to do that. Constant flow over velocity parent equals 1.01. Okay, 1% over 1. Return velocity size squared is less than k. So I do believe we need to create our is exceeding max angular speed function. Yeah. Yes, we do. Let's go ahead and head to our declaration and pull this out. This is declared public. Why don't you like it? Oh. That's weird. Okay. I would think that this is part of the functions scope, not the class scope. That's very odd. But easily to work around, so let's go ahead and declare this function. What was the return value? Virtual bool. Oh, we don't care about virtual over here. Oh, I forgot to rename it. Angular, spelled correctly would be nice. There we go. There we go. Okay, so let's go ahead and move you over here for now. Okay, so this is largely going to be a duplicate of this, except we are going to be getting the angular speed instead of the max speed. So I could just copy paste this over, but I'm trying to improve my typing and increase my understanding of how the system works. So I am typing everything out for now. I wonder what the logic is in re-implementing square. What don't you like about this? Return. So where is velocity declared? Uh-oh. Um, velocity is declared in movement component. Is there? There's an angular velocity here declared in my parent. Wait. Don't see one. Okay, that's concerning. Velocity sounds like a complement thing to re-implement. As does angular velocity. No declarations. Okay. All right. So I am going to have to drop in an angular velocity here. That's going to be annoying to implement. Okay. And I'm almost 100% certain that vector is the wrong, is wrong here. It's the wrong type. It's possible it isn't. This could be, like, we can represent roll, pitch, yaw as a vector, but representing it as a vector runs into Gibble-Lock issues. This is probably supposed to be a quaternion. Okay, we'll figure it out in a bit. Dot size. Okay. All right. So we're going to continue trying to re-implement this function, and then after that we'll think about quaternions and break my brain, I'm sure. If inputs modifier is greater than 0, and we are not typo. And we are not exceeding the max angular speed. Then angular velocity dot size squared is greater than 0. So if we have an analog input modifier, so basically we have a rotation input and we're not exceeding angular speed, and we have some velocity already. Whoops. Did I add an angular turning boost? No. So I actually don't think I want to implement a turning boost here. Unless I'm misunderstanding what a turning boost is. I'll just implement time scale equals delta time angular velocity equals angular velocity plus rotational acceleration times angular velocity dot size minus angular velocity? That I don't get. So we have our control acceleration. We multiply it by our velocity size, sure. Subtract our velocity. I don't understand that one. I think I might have to go and look at the, this is copied from the floating pawn. I'm going to have to go and look at that code. Give me a little That's the one. And then we want, yeah. Change direction faster than only using acceleration, but never increase velocity magnitude. Oh. This is for turning. I'm pretty sure this part doesn't make sense in a rotation context. So I'm going to actually delete it. If okay, yeah. If angular velocity dot size squared is greater than 0, then constant float vel size equals vel size equals what just happened? Okay, so what are we doing here? Constant float, angular velocity size. Okay, angular velocity size should never go below 0. Equals so the reason I hesitate there is if this does end up being quaternion, which I think it will, what we want to do is getting normal is different. I think it's not normalized rather than get safe normal. We will worry about this next line later because I'm not quite sure what that does. If we are exceeding max speed and we are less than max pawn speed, we stay there. And I don't know why. I'm not sure why you would want that. Oh boy. Okay. So basically, if we okay. So if we are moving and we don't have any inputs, then we deaccelerate. Otherwise, whoops, that's the wrong space. Where is this? What is this? Oh, pff, derp. Okay. Why are we doing absolute acceleration here and not just verifying that it's positive on our blueprint input? That's weird. Oh, no. That's not our that's not our max angular acceleration. That's okay. Um okay, that is stupid simple. This is the reason that it's going to be quaternion. Velocity. Whoops. Hmm. I'm starting to think I'm doing this wrong. Just so much the engine is designed around this concept that the pawn is not rotating. And on one hand, that makes no sense to me. On the other hand, I'm using spheres as my pawn. Sorry, if we're not simulating physics, the pawn isn't rotating. Hmm. But are all my pawns going to be spheres? Am I guaranteed that? I don't know. I think the answer is no. So how do these game engines handle bosses? That's my main question is the how do the game engines handle big boss fights where the boss is not a capsule or spherical collider, where you can like run underneath their legs and shoot them from below and stuff like that. I don't know. That's interesting. I think I need to think on this. If I want to use... Okay, so the big reason that I want to that I was wanting to implement angular velocity, or implement this as the pawn and not the controller, or not the camera, as the root and not the camera, is the velocity. But you can implement that, like we could implement that in the controller too. Let's take a look at the controller. I don't know. There's so much to implement. Okay. I think I will sleep on that. In the meantime, I will be... Why do I have... I don't know why we're in a different mode here. In the meantime, I'm going to see if I can... This should compile just fine, right? Yes. I want to see if I can get my new function in here. Add, suppose, we can pull it off this one. Add input, add rotation input vector. Boom. And this is where things get weird because I don't think this is right. Okay. So we've got our function over here at least. That's nice. Okay. Okay. So I think I need to consider not doing things the Unreal, not trying to replicate the Unreal implementation. Now, that's still a good starting point, but I need to start looking at how I would do this and start implementing it like that. I think we're past the starting point, basically. That's what's going on. Okay. We're past the starting point. So, let's think about our tick. we want to okay, so this component velocity, we don't have a component angular velocity to change, but we do have, I'm assuming we have some sort of component rotation, relative rotation. Let's get above the end lines here. We have relative rotation and absolute rotation to work with. If we can find it. Okay. Um, hmm. Huh. Um, if relative rotation should be considered relative to the world instead of the parent. Okay. Okay. So I do need to be using the set relative location or rotation. add relative rotation. Yeah. Okay. So, all right. So we have add relative rotation. And the other thing I want to do here is look for velocity. There's a lot of velocities, isn't there? Going towards the top. Component velocity. We just have a get and return component velocity here. We have an update and a return. Why would updating the component velocity do anything? How does that work? I would expect this to have a usage in tick. What? This doesn't do anything. And if this doesn't do anything, how does... I suppose I can look for where this is used. Get velocity. If the root component is simulating physics, get return this. If root component and root component is simulating physics, return get component velocity. Otherwise, return the movement component velocity. In the movement component. What? How is this moving our pawn? What? I am very confused. Very, very confused. Let's close this for now. Move actor. Delta equals velocity times delta time. If not delta is nearly zero, old location is this, rotation is this. Safe move updated component. I'm looking at the wrong function. Safe move updated component. Okay. Okay. Move our updated opponent by giving delta and sets rotation to new rotation. Okay, so this is just a stored variable. This is just a stored variable. It's just a helper. That's easy. That's easy. This is not doing anything. So we have, this is going to be an F quat because of this. Delta rotation equals angular velocity times delta time. And of course, this is where we get into trouble. We have to go back and fix all the quaternion stuff. And we're going to do old rotation right here, and then safe move. Note that this moves by delta and sets rotation. That's not exactly what I would prefer. I would prefer to update rotation, to move rotation by a rotation delta. And I have the option in blueprints. overlap. Here we go. Back in scene component. Isn't there an add rotation? Add relative rotation? There is. Okay. What does this do? Oh, lovely, 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 lovely. Okay. Don't know what that is. Early out for 0 case. Internal set world location and rotation. Okay, so I think I want to abstract this. I want to abstract this out. So I'm going to add some comments to well, yeah, I'm going to add some comments to help me. Okay. So I'm actually going to go back to add relative location here. What do we do on this? Update component. There we go. Add relative rotation. Get set relative rotation. Get relative rotation plus delta rotation. All right. So I think tomorrow we'll be looking into creating a function that's going to use two deltas because I don't want to. Yeah. Because this is not the right old rotation here. No, that is the right rotation. Get relative rotation plus delta rotation is the same as get component quad plus delta rotation. So I don't know if we need to implement that. Whoa. I don't know if we need to implement that or not. Because this is... I think this does the right thing. Yeah, I think this does the right thing. I'll have to trace it through, but we can try it and find out, I guess. Yeah. Let's close this. So I guess tomorrow I really need to focus on, or later tonight, I really need to focus on converting this all to quaternions instead of... Yeah. Focus on turning this all into quaternions instead of vectors. And I suppose I want to know if I can make a quaternion from a vector. Right? To quaternion. Returns returns the quaternion orientation corresponding to the direction which the vector points. Returns a result without roll. I don't think that's what we're looking for. Oops. Find quaternion between normals, between vectors, make from Euler. That sounds like what we're looking for. Sounds exactly like what we're looking for. We have an input. We turn that. We have an input that's essentially Euler, roll, pitch, yaw. Or actually, not sure what the order is, but pitch, roll, yaw. And we make that into a quaternion. That's exactly what we're looking for. Okay, so we can do that. When we do that is questionable. All right. I am going to take, I think we're going to be done streaming for the night. I will not be streaming tomorrow. I will be streaming again on Thursday. I'll see about getting a schedule set up. I will see you all on Thursday. Thank you. Have a good night.